All right, the lesson today is more so a lesson like you'd see in an algebra class. We're going to be doing some equations of lines today. So the main idea is about slopes of parallel and perpendicular lines. So we'll start about that, but then we will have to go back and review some ideas about equations of lines so we are familiar with them. So a set of parallel lines we know would look like this. They would never intersect. And what these have in common, these two lines, is they're moving up at the exact same slope. So when they're parallel, they're moving up at the exact same slope. So from this point to this point, the rise and this would be the run, and the rise amount is the exact same as it would be on this line. The rise amount and the run amount would be identical. So the slopes of parallel lines are the same. Now let me just say, like, you might say, okay, well, what if for this line, these two parallel lines, I used this point to this point, the rise and the run, and on this one to this one, I used the rise and the run. How are these the same? Oops, rise. This is run, rise. How are these the same? This one's much smaller. Well, rise over run, or slope, we write that as a fraction, rise over run. And so maybe what is happening here is that this fraction, maybe like rise over run might be 1/2. And this one, the rise over run, might be, like if we compare it here, might be 3/6, let's say. Well, are these different? Not really. They're the same value if we reduce this one to 1/2. So for parallel lines, as long as they're parallel, the key idea is that their slope, or m, is the variable we use. The slopes are equal. That means they're moving, if they're equal, they're moving up at the same exact rate. Perpendicular would look something where two lines intersect at a 90-degree angle. So if this line's going up, this line must be going down. I probably should have started here and drawn that way, but it doesn't matter at the end of the day. So one is going up, one is going down. Like this person's money is going up, this person's money is going down. So their slopes are not the same. We have, in this case, a positive slope, and in this case, a negative slope. So that's the first thing to recognize. Now this is, maybe I'll draw like another example here of perpendicular. It's purposely not perfectly like straight up and down, like if the paper was turned like that. I've slanted it slightly. If I did the rise and the run comparison here, you can see maybe what's kind of happening is like this run is pretty long and the rise is really short, versus the other line, the rise is pretty long and the run is pretty short. It's like they've flipped roles, and that's exactly what is going to happen. So let's say I was to look at this slope. This slope would be rise, maybe like rise 1/4. I'm just using a random example. And then this one would be negative because it's going down, and it would be negative down 4/1 run. So notice what happened with these numbers. The 4/1 changed to 1/4. They flipped. And if one was negative, the other one was positive. They switched there. So let me give you some examples of what would tell me like if these lines, if lines are perpendicular, and you'll see the kind of the pattern. Here would be another example. Let's say I had a slope of 2/3. If I had a perpendicular to that, it would be negative, so that one's going up, one's going down, and then the rise and the run would flip, so it would be 3/2. Let me give you another example, another set. Let's say I had a slope of 5. Let's go with -5. If that was the slope here, then perpendicular to it, let me actually draw the symbol for perpendicular. That's what the symbol looks like. That's perpendicular. So if the slope of this one was negative, and then we were going perpendicular, this new slope would have to be positive. So one's going down, one's going up. And then if this slope is 5, we'd have to flip the rise over the run. This is 5 over 1 would become 1 over 5. The word we used when we take a fraction and take that fraction and flip it is called the reciprocal. Hopefully you've heard that word before. So you might have to decide whether or not slopes of lines are parallel if they're equal or perpendicular. And the way we would describe this is they're called negative reciprocals. Negative means one's positive, one's negative. Reciprocals means they flip. Now, there could be a situation where two lines are neither parallel or perpendicular. So let me give you an example of that, which this would be neither. Neither would be, let's say, if one slope was, let's say, 4 over 3, and then the other slope was 4 over 7. Well, there's no connection. They're not the same, and they're not negatives of each other, and they're not reciprocals of each other. Let me give you another one. So let's say it was like 2 over 7, and the other one was 7 over 2. Are these parallel? Are these the same slopes? No. Are they negative reciprocals? They're reciprocals, but they're not negatives of each other. So one's positive, one's still positive here. That means they are neither perpendicular or parallel. So these lines are not related really in any way. Now, just some other things I'm going to review about slopes and lines, some things we need to know. The first would be the slope formula, which we learned these formulas at the beginning of the year. The slope formula is the rise over run if you have a picture and a graph, but sometimes you just have a coordinates, and you would use this formula for m. y2 minus y1 over x2 minus x1. That calculates the rise of the y's on top, and the run is the x's, calculates that on the bottom. Now that just tells us the slope, but let's say you want to find the equation of a line. There's multiple forms of the equation if they need it. The first one would be called slope-intercept, and that equation is y equals mx plus b, where m is the slope and b is the intercept, the y-intercept. And then the other one is called point slope form. And that equation would be y minus y1, which is a y coordinate. So this is a given coordinate, equals, I didn't need to put parentheses there. You can erase those parentheses on your paper. Equals m times x minus x1, and x1 is another given coordinate, and you do need the parentheses there because that m will distribute. Well, there's the little debrief of the lesson. Let me just put some things into our notes here. So parallel lines, the slopes are equal. Perpendicular lines, the slopes are negative reciprocals. And I'm going to put a little example here of a negative reciprocal. So if one m is 2/3, then the other m would be negative 3 over 2.